But this table right here gives you a better idea of what transformations are going to be, because you're not just going to be given the ones like, it's not just going to be square root, quadratic, and absolute value. You're going to have all different kinds, all of the parent functions. So you need to look at it more as a change to the actual function, right? So you have this function, and all of a sudden you add a number to the outside. That means you've made a vertical, outside means vertical, and then you shift it up because you added it, and you're adding to the whole thing. Versus down here, look at this one. This one, the plus c is inside the function, right? I actually did it inside the parentheses. That means it's a horizontal, which is inside. And we shifted left, so we added backwards, backwards. Backwards, always. Okay, let's look at this one. This time now we're subtracting c, some number, which makes it a vertical shift down because we subtracted, and again it's outside because it's vertical. So vertical always makes sense. If you're shifting something up, then adding to the function makes sense. If you're shifting something down, subtracting makes sense, right? Up, positive, down, minus. But when it comes to horizontal, and you're going to hear me say this 500 times, I probably already said it 100. If you're doing something inside, which is a horizontal change, then it's always backwards of what you'd think. You would think horizontally, if you're moving to the right, then you're moving in the positive direction, you would add it. It's backwards, backwards. What? Backwards again? Anytime it's horizontal, it's backwards. We should highlight that. We should make sure you can see it for sure. Horizontal, backwards, horizontal, backwards, right? Always. All right, moving on to reflections. If you have a sign change, a negative, to the whole function. So out in front is usually what happens, but you're really multiplying the whole function by a -1, which just changes everybody's signs. This is the reflection over the x-axis. So over the x-axis, you would be multiplying everything by a -1, doing it outside. But all it really does is change everybody's signs. Most of the time, it's literally putting a negative out in front, and that's what changes it. Sometimes it gets a little bit different though. Now inside is a different story. We're reflecting over the y-axis, and you're multiplying only the x by the -1. And this kind of little side note, anything that's inside with the x. So let's say our function at one point was this. And then I said, oh, reflect it over the y-axis. And according to my directions right here, it says to multiply only the x by -1. Well, it's -1, but it gets multiplied by everybody inside. So that's what this little bit right here is talking about. You would actually multiply everybody inside. Everybody. I guess it's not everyone, it's everything. I mean, I tend to refer to it. Man, do you see that shift again? Everything. Okay. All right, now these are called non-rigid. You don't need to know that word. These are the stretches and shrinks. Vertical is so easy. You don't even have to think twice about it. When you do a vertical stretch or shrink, you multiply outside. And you're going to multiply the whole function by it. Couldn't pick a color. But that's the idea, is that you multiply the whole function by whatever A is. Whatever you're doing a stretch or a shrink by, you're going to multiply on the outside. Not inside parentheses or absolute value bars or a square root. It's everything outside. Now, if it's a stretch, then your A will be bigger than 1. Duh, that makes sense. If you're multiplying by 2, stuff's going to get bigger. Versus when you're multiplying by a number in between 0 and 1, it's going to shrink because everything is getting smaller. Now, let's go to horizontal. Right away, you need your brain to start saying something inside it. It should say this word, backwards. Horizontal's always backwards. Backwards. Do, 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 do. Horizontal. Highlighter. Highlighter. Ooh, I shouldn't have highlighted. Stretch. Highlight. Horizontal. If it says horizontal, it's backwards. Now, because we're multiplying, the whole backwards part of it is the fact that instead of multiplying by a number that's given, you're actually multiplying by its reciprocal. So A is the number that's the reciprocal of whatever it said. Now, this one you need to see an example of. So if it was, let's say we had a horizontal shrink by 1/2. This is the number right here. So A is actually 2. It's backwards. And again, this is just an outline of it. I have this on paper to give you guys, or it's just online. This is something to refer back to, but you have to see examples for it to really make sense. Inside, outside. If A is greater than 1, it's actually a shrink because of the whole reciprocal thing. So there's opposite. If it's a fraction between 0 and 1, the A, then it was actually a stretch. And again, those need practice before they'll make a lot of sense. This horizontal thing is messed up, so we always save that one for last. Okay, let's just try these. Name the parent function. So you've got your whole list of parent functions. What you have to identify is what was the f of x that went along with this function. Well, if you look through your parent functions, this right here tells you that it was the cubic function. Okay, first step, that's your parent function. Now, looking at this parent function, go through and say, okay, what changes have made? It was just this x to the third. Now I've got this 1/2 and this -2 out in front, or sorry, at the end of it. Now pay attention to operations. This is 1/2 times, and this is -2. So we are multiplying by 1/2, and we are subtracting 2. Your next question is to say, is that happening inside or outside? Well, how do you tell the difference with a function like this that has no absolute value bars or square roots or anything? Well, here's the difference. If it were x cubed inside, it would put parentheses and put a cubed up on there. This is a typo again. Geez, lady. Way to be unprofessional. So just like down here, see how it's got parentheses instead of just x squared? They put a bubble in there. That's how you expand it out to make a quote-unquote inside. Okay, so back to this one. We are talking about inside. So I outside by 1/2, and I subtracted 2 outside. So if you go back to your little reference sheet here, if I'm multiplying outside, then it's a vertical stretch or shrink. I go, okay, I'm multiplying by 1/2, which falls into this category, which makes it a shrink. So to describe this one, you would say vertical shrink by 1/2. Vertical is nice and easy, it makes sense. Okay, now we're also subtracting 2 outside. It's not subtracting, that's this one right here. Right here was my function, x cubed, and I minused something at the end. That's again vertical, shift down, and then it's whatever number you're doing it by. So this one would be vertical, shift down, because we're subtracting 2. Okay, identify the parent so you know what it was supposed to look like in the beginning, and then just go through and identify any differences that there are between them. This one right here, this is f of x equals the absolute value of x. That's where we started from. That's the parent function. You can tell because of absolute value bars. Now I'm going to go in and highlight any differences. So this plus 3 wasn't there before. This minus wasn't there before. And this 2 times was not there before. Quit it. There we go. Look, and there's dots because every time my hand touches it. Okay, so let's describe each one of these. Let's talk about where each one happened. I don't want a crayon. Let's see, this one right here, we're adding 3. And where does it happen? Is it inside the absolute value bars or is it outside to the whole thing? That's an outside. Okay, this right here, there's now a negative. It was just an x inside before, right? There's a negative. And like I said, inside the absolute value bars, so a negative inside. And then we've also got this 2 right here, and the 2 is multiplying. Multiply by 2, and again, that's inside. Okay, one at a time. Let's see, adding 3 outside. I know what it means to do add 3 outside, right? We already learned that outside, adding, vertical, shift up. Those are the easy ones to remember. So this is a vertical shift up 3 because we added. Okay, let's go back to our reference sheet. Let's talk about that negative. This was the negatives, right? We either had a negative out in front of the whole function or we had a negative just applied inside to the x. Looks like it happened inside. So we would say that one is a reflection over the y-axis. So we're going to say reflection over the y-axis. All right, multiply by 2 inside. Automatically, inside your brain needs to go, want. This is backwards, want, something's wrong. Then you go, okay, I'm multiplying. Multiplying was these stretches and shrinks. So we know it's inside. We know something's going to be weird. So it's either a horizontal, or sorry, we know it's inside and it's multiplication. That means it's going to be either horizontal stretch or a shrink. So I know it's going to be a horizontal stretch or shrink, and then it's going to be by a number. It is not by 2 when you're writing it out. This is the original number that you multiplied by, which means the actual change is the reciprocal. Reciprocal. So whatever number is inside there being multiplied, when you go to describe it, you describe it using its reciprocal. Backwards. Everything's backwards. So if I say it's a horizontal blank by 2, that has to be a horizontal shrink by 1/2. All right, let's try another one.